Hello class, this is actually Ms. Peterson this time. I'm recording our 7.1 notes this time. We're going to start with 7.1, it's operations on functions. So if we look at our first problem, we have that Carol owns a store where she sells birdhouses. The revenue from birdhouse sales is given by R of x is equal to 125x. We also know that the cost of making this birdhouse is given by C of x is equal to 65x plus 5,400. Our first question, how would you find the profit of Carol earns on her sales? So if you remember from our chapter 6, we learned that profit is equal to our revenue minus cost. Right. So finding out the profit of Carol earns on her sales, let's see. So once again, I guess we'd write P is equal to our revenue minus cost. We could have just written that down here. So writing a profit function for Carol's sales, we know that our R of x is equal to 125x. So we have our P is equal to 125x, and we're subtracting our C of x. So our C of x was 65x plus 5,400. Notice that I put this in parentheses because we're subtracting the whole thing and we're not just subtracting the 65x. So if we simplify this, let's see here. Right, so P is equal to 125x. And if we distribute our subtraction, or negative 1 here, we have a negative 65x and a minus 5,400. Then combining like terms, we have 125x minus 65x, that's equal to 60x, and then we have our negative 5,400. And this would be our P of x, our profit function. So today, what we're going to be doing is we're going to be doing operations on functions. So basically adding functions together, subtracting them, multiplying them together, and dividing them. So let's see, so they're given, we're looking at the sum of two functions first. So we have f plus g of x. So really we can rewrite this as f of x plus g of x. All right, so basically you're just going to be combining like terms. So if we look over to our right here, we notice that we have an example we can work with. So we're letting f of x equaling x plus 2, and g of x is equal to 3x. So we're going to add the two functions together. So f of x plus g of x is equal to, so our f of x was x plus 2, and we're adding our g of x, which was 3x. So combining like terms, we have 1x plus 3x, so that gives us 4x, and we have plus 2. All right. So now looking at the difference of functions, we have f minus g of x. We can really write this as f of x minus g of x. So just kind of like the sum, we're going to be combining like terms, but before we combine like terms, we're going to distribute that subtraction sign first. So distribute subtraction sign, then combine like terms. Kind of moving over into this other box here. So if we do an example of this, so we're subtracting f of x and we're subtracting g of x from f of x. So f of x minus g of x, that's equal to, if our f of x is equal to x plus 2, and we're subtracting our g of x, which was 3x. I always put this in parentheses to make sure I'm distributing the subtraction sign among the whole quantity and not just the first term. So we have, if we distribute our subtraction sign, we have x plus 2 minus 3x. And combining like terms, we have 1 minus 3 gives us a negative 2x, and then we have plus 2. And that's our f minus g of x. All right. Next one is looking at the product. We have f times g of x. This can be written as f of x times g of x. We distribute our terms and then combine. So distribute our terms. and combine. All right. So if we're multiplying our two functions together here on the right, so we'll have x plus 2, we're multiplying by g of x, which is 3x. If we distribute our 3x, we have 3x times x gives us 3x squared, and then we have 3x times 2 gives us 6x. And that would be our f times g of x. And for our last operation here, we have the quotient. So we have f over g of x. We can write this as f of x over g of x. One quick note here, g of x cannot equal 0. It's on the bottom of a rational expression, and we can't divide numbers by 0. It doesn't exist. So the first thing we're going to do, or what we're going to do here, is divide each term. Divide each term by each on the bottom, or by the bottom. So divide each term on top by the bottom. And I'm actually going to do my example down here. All right, kind of ran out of room. So if we have our f of x is equal to x plus 2, we have x plus 2. We're dividing that by our g of x, which is equal to 3x. If you remember, when we divide something by a monomial, we can take the top separately divided by our bottom. So if we have x over 3x plus 2 over 3x, so these x's, we can get rid of those, so we're left with 1 over 3 plus, and we have 2 over 3x. We can't really reduce that any further, so we're left with 2 over 3x, and this is your answer. So we'll go through a couple examples. If you need, you can pause the video at any time to write everything out, or if you need more time to write stuff. But if we're going to move forward, so we have our... All right, so moving on to our first example. So given f of x is equal to x squared minus 3x plus 1, and g of x is equal to 4x plus 5, we need to find the following. So our first example is if we have f plus g of x. So what we're really doing is f of x plus g of x. So our f of x is equal to x squared minus 3x plus 1. So write this in parentheses. So x squared minus 3x plus 1. And then we're adding our g of x. So our g of x is equal to 4x plus 5. So what we're really going to be doing when we add the two functions together is we combine like terms. We only have one x squared term, so we can write that down here. We have a negative 3x plus 4x gives us a positive x. And then we have our constant terms. So 1 plus 5, that gives us 6. And this is our new function. This is our f of x plus g of x. For our second example, they're asking us to find f minus g of x. So once again, we can write this as f of x minus g of x. And our f of x is equal to x squared minus 3x plus 1. And then we're subtracting our g of x. Remember to put your g of x into parentheses so that we distribute our subtraction sign throughout the whole thing. So 4x plus 5. So distributing our negative sign throughout our g of x. So we have x squared minus 3x plus 1. And so we have a negative 1 times 4x gives us a negative 4x. And a negative 1 times a positive 5 gives us a negative 5. And from here, we can combine like terms. So we have only one x squared term. So x squared, we have a negative 3x and a minus 4x. So negative 3 minus 4 is a negative 7x. And then a 1 minus 5 gives us a negative 4. So our new function, or f minus g of x, is x squared minus 7x minus 4. Moving on to our next example. We have two new functions. We have f of x is equal to x squared plus 5x minus 1, and g of x is equal to 3x minus 2. And we're going to find the following. So the first example we're going to do is f times g of x. We'll rewrite this as f of x times g of x. Our f of x function is x squared plus 5x minus 1 times 3x minus 2, our g of x function. So you can do this two ways. You can kind of FOIL this, as in distribute your 3x to every term over here, and then distribute your negative 2x to, or your negative 2 to every term over here, and add all the terms together. Or we can use the box method that we went through in class. So if we use our box method, we have 3 terms here, 1, 2, 3, and 2 terms here. So we need to have a 3 by 2 box. So if we put our 3 across the top, we have x squared, 5x, and a negative 1, and our 2 terms on the side, so 3x and a negative 2. So if we find the area of each box, so we have 3x times x squared gives us 3x cubed, 3x times 5x gives us 15x squared, and 3x times negative 1 is a negative 3x. Moving down to the second row, we have our negative 2 times x squared gives us a negative 2x squared. Our 5x times negative 2 is a negative 10x, and negative 2 times negative 1 is a positive 2. So here we're just combining our like terms. Notice that our like terms are in diagonals. So if we have our 3x squared, 3x cubed here, so we have 3x cubed. We have a negative 2 plus 15, so we have a positive 13x squared. A negative 10x and a negative 3x, it's a negative 13x, and then we have our one constant term, so plus 2. And this would be our f of x times g of x function. Moving on to our last example for the day, we have our quotient property, or quotient kind of operation. So we have f over g of x. So our f of x is x squared plus 5x minus 1. And this is all over our g of x, 3x minus 2. We can solve this using long division. But we can also just leave this in our simplified sort of term or form, x squared plus 5x minus 1 all over 3x minus 2. There's no really reducing it. We can't take our top terms and divide it by 3x minus 2 because this isn't a monomial. So we're just going to leave it like this. And the rest of the notes we'll go through in class like usual. Don't forget to take your Schoology quiz, and I'll see you tomorrow.